All right, in 7.3, we're going to be looking at the reaction quotient, which is represented by Q, and we're going to compare that to the equilibrium constant K. So one of the things that you need to kind of remember here is, what is each one? Well, if you remember from the previous video, we had already established what K was. K is the value where equilibrium is going to be established. So for us, what we want to do here is essentially, let's just move things over here to the little bit to the left and identify these from within that reaction. And so remember, we had the reaction like this, and I'm just going to represent one of the reactants. The reactants was represented in red. Let's call it R. And then the other one, let's say blue, was here at the bottom 0, and it increased that way, and let's call this P for products. And eventually there was a point where they flatlined, and this point here was K. Now the K value is important, so if they ever provide that number, remember that there were a couple of items here that we needed to worry about. So K was equal to 1, which is what is observed here at equilibrium, when the concentration of the products and the reactants are there, are equal to one another. Then there were a couple of other options here where K was greater than 1 and where K was less than 1. Now, we're not going to go over those in greater detail in this video, except to just say that when K is greater than 1, then the products are favored. The higher the value greater than 1, the more strongly or more pronounced the products are going to be favored. And in the opposite direction, when K is less than 1, that means reactants are going to be favored. So you're going to get a lot of reactants still present unreacted in the solution mixture. Now, how does Q fit into this? Well, if K represents the goal, and we can just say generically here, this is the desired part of a reaction where it wants to be equal. Think of it kind of like the goal for balance state in terms of concentration. Then Q is literally going to be a way that you can evaluate where in the reaction process you really are. If you're going to be before it, at equilibrium, or after equilibrium. So Q then can have a couple of designations as well. Just like we had established with K over here, with K equals 1, greater than 1, or less than 1, the value Q needs to be calculated. And so remember, we had said that if we had a very generic equation, let's just put one here on the bottom for us really quick. Now here's the expression for K for this generic example of a reaction. But this is the way we solve for K. How do we solve for Q? Well, the reality is that we can use the exact same format, and instead of using K, literally we can just come in here and replace this with Q. It's the same exact reaction setup in terms of the expression, but what you're going to be doing is that you're going to be calculating Q instead of K. So rather than kind of doing this, let me go ahead and back up, show both equations on both sides so that I can illustrate the point a little bit further here in the example that I'm going to provide next. So here are the two reactions, or at least the setups for the equilibrium expression over here on the right-hand side. We've got K, and the same setup for Q on the left-hand side. So what we're going to do here is we're going to be comparing the different values of K relative to Q. And just like we had identified previously for K, we can do a similar thing for Q. But remember, K is a value that's provided. It tells us when equilibrium is going to be. It's an established value. And what you're going to do in a reaction equation where they're asking you to really answer the question, are you before equilibrium? Are you at equilibrium? Or have you gone past equilibrium? We're going to typically use the value Q, and then we're going to compare. But let me give you what those rates are going to be. So Q can be equal to K, in which case you are at equilibrium. Q can be greater than K. That means that you've gone past it. Let me move this back. Okay, and then finally Q can be less than K, which means that you are not quite there yet at equilibrium. You're just before it. And so if we take a look at the graph that we've got up here, let's go ahead and take a look at when Q is equal to K. All we're saying is that Q is going to be right here. you're literally at the same spot that K is. And so the value that you calculated or was provided for K, if you calculate Q using the formula here for the expression, the value that you get here should be equal to K, and that puts you right here at equilibrium. On the other hand, if you calculate it and say the value comes out to Q is greater than K, so when I take this expression, solve for K, and I compare it to the K value provided, another instance could be that Q is going to be back over here, behind the equilibrium point. And so this particular case here indicates that you've gone past equilibrium. And the reason we want to know if we've gone past it, which is going to be the focus of another section here, is whether the reaction is going to shift in the opposite direction towards equilibrium so that we can reestablish it. All right? So that's the second instance here where K is greater, or Q is greater than K. And then finally, the last expression, or the last place it could be, would be if Q is right over here on the left-hand side. And so if you go ahead and calculate Q using the expression here, compare that value to K, if Q is less numerically than the value of K, then graphically, this is where you're at. You're over here on the reactant side of things. We haven't quite reached equilibrium, so that means that the reaction is going to proceed forward until we get to equilibrium. So these are the different instances of that, and the only thing that I'm going to do here is zoom in a little bit so I can make some clarifications on this, and this is where we'll end it for us for today. Here, this is Q is greater than K. This instance here is where Q is equal to K. And in the instance down here on the far left, this is where Q is less than K.